Today, we are talking about a battle more complex, prevalent, and dangerous than any other. You are being involved in it without even knowing it. You know it's happening, yet you don't. Let me clear all confusion today, right now. Phosphorus, radium, sodium, vanadium, pranav, and are on your screen, and today, let's talk about the internal battle between microvillains and the human immune system. Drama aside, this is a very important video, seeing the precedence and prevalence of many diseases. Subscribing and sticking around to the end of the video would help you by showing you some of our body mechanisms and answering some of the most intriguing questions, and help me by encouraging me to make more interesting videos like this. So in the immune system, we have two layers of protection: the innate or the non-specific, and the adaptive or the specific immune systems. It is already so hard for the microbes to enter the body simply because the innate immune system doesn't give a poop about who it kills. Anything that is foreign to our life gets its life sentence. You can kind of think of this as security guards, you know, those who prevent intruders from casually popping in and colonizing our entire body. There are 4 different mechanisms of this immune system. Let's cover them. Timestamps are given in the description. The 4 mechanisms are anatomic, physiologic, endocytic, and inflammatory. The anatomic immune system refers to the physical barriers that prevent the microbe from getting into your body. The most common barrier is, well, our largest organ, the skin. That's why people apply bandages on top of wounds. A hole in your skin can definitely permit microbes to enter. Our hair also kind of traps microbes, making sure they don't enter. Notice the hair inside your nostrils? Yeah. But let's say somehow the microbes still entered the body through the more common entrance gates, like your mouth or nostrils. Sorry about this guy's face, I'll remove his freaky eyes, nose, and mouth. Mucus lines your respiratory tract and your digestive tract, which is sticky enough to trap microbes. Mucus pretty much handcuffs the microbes, since it's pretty much immersed in goo. Since we are conveniently at this diagram of the digestive tract, we should start discussing the physiological immune mechanism. The physiologic immune mechanism is the chemical way of defeating microbes. For example, gastric juices or digestive juices in the stomach contain hydrochloric acid. This hydrochloric acid creates an acidic environment in the stomach where germs fail to survive. Fevers are another physiological mechanism. The oh my, it's been a long time since I used you, bruh. Anyway, the hypothalamus or the heat regulator in the brain, located somewhere over here, responds to germs or their products by raising the body temperature. High temperature results in the death of microbes, as most of them are unable to cope with such high temperatures. Next, let's look at the endocytic mechanism. Endo means inside or inward, and cytes means cells. So using some common sense, endocytosis is the taking in, endo, of foreign particles by cells, cytes. Wait, what? I think that immune cells just straight up Pac-Man the microbes up? Well, indeed. So let's zoom into it. Even more. Okay, that's good. So this right here is a phage, or an immune cell. Specifically, this is a macrophage. These macrophages extend their plasma membrane or cell membrane and just engulf the foreign particle. This vesicle binds with lysosome, which is the part of the cell that contains a whole lot of enzymes that break the germ down and kill it. Neutrophils and dendritic cells are also involved in similar processes. Lastly, we have our inflammatory mechanism. This is my personal favorite because I get it all the time. A common rule of thumb should be that whenever something ends with itis, it is a form of inflammation. Dust allergies like allergic rhinitis happen not when a rhinoceros gets inflamed, but rather when your immune cells, while patrolling the body, spot a dust particle. Rhine has something to do with the nose, from the Greek word rhis. Let's get more nosy now. The immune cells think this is some intruder and cause the blood vessels around the particle or the germ to dilate and increase blood flow. The endothelial cells that line the walls of the capillaries separate, creating a leaky wall through which fluid passes through into the body tissues. This causes swelling, also known as inflammation. So those were the 4 immune responses of the innate immune system. Remember that all these responses are triggered by our system whenever it sees any random foreign particle. At first I was thinking about making a separate video for the adaptive immune system, but it's not that hard to understand, so I'm gonna summarize it in 3 minutes. Okay? 3, 2, 1. Alright, the adaptive immune response has 2 divisions: the cell-mediated immune responses and the humoral immune responses. I'm kind of short on time, so no cartoons for this segment. Let's first understand that an antigen refers to fragments of a pathogen that stimulate an immune response. So in the cell-mediated immune response, the antigen-presenting cells, or APCs, snitch on the antigen and get it into trouble. This goofy group of cells consists of the B lymphocytes, or B cells, macrophages, and DCs. No, not that DC. I meant dendritic cells. These cells, as part of the innate immune system, perform endocytosis, pac-man up the antigens and present them in front of their bosses, the cytotoxic T lymphocytes, CD8+, or cytotoxic T cells. Lymphocytes are a type of white blood cells. Remember that cytes, or cyto, or cytic refers to cells. There are many different types of T cells that we will see soon. The cytotoxic T cells mainly kill the human cells that have been infected by an antigen, and we will call these group of cells as target cells. The naive T cells mature into armed effector T cells once they encounter the specific target cell. I'm not making any of this up. These are real names. You know, just like how we have Tom, or John, or Mary, or Susie, or whatever, we have armed effector cytotoxic T cells. It makes sense, right? Yeah, sure, whatever. T cells mature in the thymus. The armed effector cytotoxic T cells, or effector CD8+ cells, then kill the target cells. And these guys don't leave it at that. They then remember this microbe very, very well. In fact, this is how cancer cells are killed. The humoral immune system instead approaches antigens in a more systematic way. I'll stop. Instead of killing target cells, it kills the antigen itself. The OIC of the humoral immune system are the B lymphocytes, or B cells. Just like how T cells mature in the thymus, B cells mature in the bone marrow. You can kind of see the pattern here. To kill antigens, antibodies need to be generated. Helper T cells CD4 help in antibody production and immunologic memory by binding to B cells. This releases cytokines that help B cells divide rapidly into 2 types of cells: plasma cells and memory cells. Plasma cells leak into the extracellular fluid, which is the fluid between a blood capillary and a cell, and is known to be the naval base of antigens. Yeah, I made that name up. Plasma cells produce antibodies in the extracellular fluid that fight with the antigens and, well, bring back some good news for us. Hopefully. Memory cells, on the other hand, remain inactive, but when the next wave of this pathogen enters the body, it's like, no, not you again, and divides into plasma cells, and, well, yeah. Was that under 3 minutes? Probably. Even though the human immune system is quite hard to understand, all these components work together in order to win the eternal battle against pathogens in order to keep us safe. This really shows that teamwork makes dream work. Click the links in the description below to learn about the human circulatory system and blood cells. I hope this video made your day a little bit more meaningful. Do consider liking and subscribing. I'll see you soon. Peace! I can finally reach the camera.